All right, so as Mike said, my name is Keith Babo. I work in the product management area of Red Hat with a focus on integration, which I guess is good news for us because I'm going to be talking about an API-focused approach to Agile integration. So quick schedule, if you're checking your home game. Schedule is kind of reversed here. I actually get to be the person that warms up the crowd for Christian Posta. So I'm the opener. Oh, did my mic? There we go. All right. Normally we only have 45 minutes. I've got a ton of stuff to do. Like I want to show you a bunch of stuff in slides. I have a demo. Want some questions. Apparently I have a reputation which precedes me because everybody else is like keynote, but for me, it just says go faster. So I'll take that hint. I certainly don't want to prevent you from getting to Christian as fast as possible. So let's have at it. So the first thing, I love starting these talks with big numbers, and these are some really big numbers. When you look at how many, by the year 2020, which is almost just 2 years away, we're talking about having 26 billion interconnected devices. That's a lot. That number's humans. Skynet will be a reality, so I guess we don't really have to worry about it that much. But when you think about this, that means that the interconnects between those 215 trillion stable connections, right, and 63 million connections per second. Now, I'm certain that these numbers encompass IoT devices, right? Just devices are all over the place. But the thing is that when you look at these numbers, maybe they might not all be APIs, okay? But they're only 1 or 2 degrees separated from APIs. So those devices, they talk to gateways. Those gateways talk to backend systems through APIs, right? So APIs are going to be absolutely critical. They're, as we saw from Steve's talk earlier, super critical now for digital transformation and just participating in the API economy, but only going to get more so, right, as we expand. So this introduction of APIs, and just, I think, a recognition in general of the complexity of these laws of big numbers, right, are forcing 2 fundamental shifts within enterprise IT, okay? One of them is a technical and architectural shift, which is depicted here. So I'll start with that. And the idea is, if you look at the top row there, it's stuff that we've been doing all along. So Samir was mentioning, ESBs, hub and spoke type integration, traditional EAI type of stuff, right? And to do that, we maybe use service-oriented architecture. We did SOAP-based web services. All these things were monoliths with the ESB intertangled with them, right? And we deployed them in a waterfall type of model on bare metal or maybe VMs, right? And we certainly didn't have any cloud aspirations. Now, there was a question I thought was a very good question earlier, which is that, is this evil, right? Is it inherently evil and something to be despised? And the answer is no. It was ESBs and EAI developed over decades, right? To be a very efficient solution to a certain class of problem, okay? But what we just saw is that the problem domain is changing, okay? So we can continue to use these technologies to solve yesterday's problems, but tomorrow's problems, these technologies will not scale, okay? Second point I want to make is about organizational changes, okay? So we talked about some technical changes, where that's going from, SOA type of architectures to API-based architectures, doing containers and cloud and this type of thing. But organizationally, there's a major shift too in terms of the participants in integration infrastructure. So in the classic days, does this have a laser pointer? Yeah, no way you'll be able to see that. But that ninja on the far left there, right? A lot of enterprises call this an integration competency center or a center of excellence. Basically, it's this ninja team of people that have been doing integration for a really long time, okay? They're domain experts. They understand the products that they're using for integration inside and out, and they know all about best practices for integration, which is a great thing to have. The problem is, with any great thing, right, bottlenecks get introduced. Right now, these people are a problem because they want governance. That's a good thing for the business, but it slows us down. We can't get to market in the time we want to do a lot of times with the ICC involved, and this is a fundamental problem. And to address this problem, we've seen kind of 2 paths. One path is that you have line of business type folks say, well, you know what, I'm going to completely circumvent my internal IT groups, and I'm going to go to the cloud. Exactly as Maureen was saying earlier. I'm going to purchase SaaS-based applications or do some custom development, really lightweight development in the cloud, and I'm just going to completely go around this group, right? And flanking from the other side is the microservices movement, which Christian will talk about in a little bit. And in the microservices movement, the idea is ownership, right? You write the code, you deliver the code, you support the code, you wear the pager, you eat all the pizzas, Okay? And that's the idea, is that they want to own everything. The ICC is not involved in that process, right? They're completely running their own operation and delivering that code into production. So really, really kind of fundamental existential threats to the ICC as we know it today. But the key thing is that the ICC is fundamentally a good thing, right? We want best practices. We want detailed knowledge of the technology we're using to deploy, right, and create integrations. So we need to find a way to basically harness that power, but distribute it across the groups like the line of business users and the microservices teams that need integration. So both of these are symptoms of a lack of agility, right? What we're saying is that we value going from an idea to code running in production. That's what we want to do. And we cannot do that in an agile or speedy way today. And there's lots of reasons for that, right, that we just kind of talked about. So one of the things we have to ask ourselves is, how can we get more agile? How do we help companies realize not just going from idea to code, but that code deployed into production, measured not in months or years, but in hours, days, minutes kind of thing. And so working with IDC, there's some basic parameters here around agility that seem to be constant in the marketplace. One is modular deployments, deploying as containers, right? Another is this idea of breaking down these monoliths into more modular components or microservices. You don't have to go full microservices, right? But actually thinking about, hey, if I made these more modular, maybe exposed an API, like how would my organization benefit from an agility standpoint? Maybe if it's smaller, I can deliver that unit of work in a much faster way than I can of regression testing a huge, million-line code base type of product. But finally, and a key point here, is the need for decentralized integration. So we can't build this around the architectures that we've been using so far, right? We need to put integration where it's needed, where these teams are using integration. So Red Hat, as you saw from Samir's talk earlier, so I don't have to go into detail, has an opinionated philosophy about this that we call Agile Integration. So I'm not going to rehash any of that, other to note that the pillars of Agile Integration apply here. What I want to do in today's talk is, based on our experience talking to customers and workshops and conferences like this, what we think the drivers for Agile Integration. So what are the real tangible elements that drive this need for Agile Integration? And we find they kind of break down under three axes: strategic, technical, and line of business. I'm going to go into more detail on that in a second. So let's start with strategic. Normally how strategic works is like the CXO or leadership team of your organization goes to a resort over the weekend or locks themselves in a boardroom, and then they come back and they say, agility, cloud, right? Digital transformation, right? And then it's up to everybody to figure out what the heck that means and how you're actually going to implement it. So we're just talking about agility all day today, so I'm not going to go into detail there. Steve had a great talk. Personally, I believe around digital transformation, the easiest way to get to digital transformation as a first step is through APIs, right? The concept of digital transformation is that as an IT or a software-based organization, we're contributing to top-line growth, right? Increased revenue. Our products are more valuable as a result of our IT infrastructure. And APIs are an excellent, excellent way to do that. So what I want to double click on is cloud adoption here and really focus on when we think about moving to the cloud, right? And as Maureen talked about earlier, everybody's talking about the cloud, right? And we're getting more aggressive and we're getting more serious about the cloud. It's not just sandboxing and dev anymore, it's actually production apps, right? So when we look to go to the cloud, like what are some of the things we need to keep in mind when we do that? So in working with customers, our consulting teams and our architects, we find there's three general patterns in terms of moving to the cloud: lift and shift, connect and extend, and rip and rewrite. So let's start with lift and shift, which you've probably heard a lot about before. Gosh, it would be, I don't want to point at this one. It'd be easier if I could point at this stuff. So let's say when you're doing a lift and shift type of operation, so on the far left there, here's where you're starting, right? You have some databases, config, files, whatever, and then you've written your classic three-tier app maybe, right? So UI, controller layer, and then backend. And so what you want to do is, instead of saying, you know what, the first step is going to be rewrite everything, redesign, maybe you don't have those skills, right? Let's actually just take those existing components, right? The business logic, the UI layer, and the persistence access logic, right? And we'll containerize that. And we'll move that to a container platform. Now, that's not realizing the full value of a cloud-native architecture or container-native architecture, but there's definitely value there, right? If you containerize that, all of a sudden you can scale it. You've got centralized management and monitoring, right? You've got advanced deployment topologies that you can bring in, right? Whether that's a rolling upgrade or blue-green type of deployment, ABs, all this kind of stuff, right? So you get process level isolation, failure detection, really, really good value for existing apps that you don't have to change at all other than containerizing them. But the goal, of course, is to use that as a stepping stone. So once you've arrived at the containerized platform, you have operational experience in operating that platform, then you can opportunistically move to start doing some more greenfield development and converting these applications over. The range on this seems limited. All right. The second pattern is rip. Oh, no, it skipped twice. All right. Connect and extend. So this is a really cool one, and if you're looking at a primary option, this is the one I recommend. And the idea here is instead of lift and shifting our existing application logic, what we want to do is just leave it as it is, okay? It doesn't have to change at all. And what we're going to do on our container platform is implement a facade or delegate layer, okay? So I'll implement some APIs that basically provide access to those back-end pieces of logic, okay? All of the clients, whether it's outside of my organization, it's partners or customers, or it's internally, they will all go through these APIs. Steve was talking about how important APIs are a contract as a stable representation of your functionality, and this is exactly what you want to build here, right? A stable API base that delegates back into this back-end infrastructure. You can do greenfield type of development in there, you can do full microservices, or you can just do little modular or majestic monoliths, right, with these APIs, totally up to you. But the idea is that these are purpose-built containerized APIs that don't take the full expense of rewriting everything, okay? Then you have the luxury, again, of getting operational experience there. You have the development experience of putting the APIs into production, and you can gradually start to move your existing back-end stuff over as you need to. And then finally, this is kind of the nuclear option, rip and rewrite. And the idea being that, basically we're going to cancel what we have today and we're just going to write it all from scratch. I've never met a customer that's done this, actually. But I think it's actually valuable to think of it more in terms of this intermediate state, going from column 2 to column 3 is kind of like a rip and rewrite at a micro scale, right? So my advice would be, it's very difficult to imagine a project getting off the ground for a significant business critical app that's a total rip and rewrite, right? So think instead of positioning that as, hey, we have a strategy how we're going to gradually move over, improve our experience on this platform, prove it out as a solution, and then we can start targeting these things and rewriting them. And when you do that, and this is something that actually came up in the Q&A, which I thought was a great conversation, and for the record, I had this slide in my deck for that conversation, is the idea that when you do move to cloud, what are the things you need to look for, right? First is, where are you deploying cloud? For a lot of our customers, private cloud is the first option, right? They have a public cloud mandate to go to the public cloud in 2 years or 5 years or whatever, but they're starting private, okay? What does that mean? Does that mean you're adopting a cloud solution on premises, and then you're going to have to switch it up when you move to self-managed public cloud? And then what about, then again, if you have a vendor managing your platform, right? If it's vendor managed in the public cloud. So what you absolutely need is a platform that's going to have the same APIs, that's going to have the same processes and functionality, right? No matter what environment you're working on, so you don't have to rewrite everything again, because you will probably be moving between these environments over the scope of time, okay? The second piece is, and Maureen pointed this out in the Q&A, is isolating yourself from vendor-specific APIs and functionality, right? The last thing you want to do is make a big bet on a given provider, and next thing you know, they're doubling their rates every year on you, right? Or they're no longer implementing new features or fixing the bugs that you're reporting in their platform. So what you need is an insulation layer to basically, and look to open standards for this, like Kubernetes, to say, hey, I can run on a Kubernetes platform that basically provides this portability across providers and across locations, whether that's private or public cloud. So next I want to go into the technical drivers here. So a lot of times these can be the result of the strategic conversation. People say, do cloud now, we need agility. Technical team meets and they say, okay, now we need to think about cloud native, or we need to think microservices. And we need to think about doing APIs. Sometimes developers just know this is intuitively a good idea for new development. This is what we're going to be doing. So what I'm going to do actually for the sake of time is smush these down into one story almost, or one narrative. So let's talk about, let me preface this with 2 slides before we get to the story. First is more an extension of my previous point around an open hybrid cloud is the idea, and Maureen, I believe, also mentioned this, is the idea of a tool chain on top of these clouds. So if you're new to container-oriented development, there's a lot to think about, okay? It is not simply zipping up whatever you were doing before and dropping it in a container. We talked about that as a strategy, but that's not doing container-native development, okay? If you're doing container-native development, you have to think, what are the tools you're using to create those apps? Is it the same tools you're using today, right? When you're creating applications, when you're writing code, are you going to use the same IDE, the same building tools, right? Or are they different? When you actually go to target a runtime for that app, is it going to be compatible with container architecture, right? So that's a really, really critical point there. If we look at some technologies out there like Spring Boot, right, and fat jar type deployments, they're built around this concept of small independent microservices that have limited dependency graphs, okay? And that is great if that's your type of application. If you have a larger application with a really deep dependency graph, then you need a tool chain that accounts for that. So that's the second thing to think about. The third is, once you have that app, how are you containerizing it, right? What are you using to actually generate that container and get it to deploy into a container platform? And then, of course, there's the deployment APIs. So there's this basically chain of you writing code in an IDE all the way to getting deployed on a container platform. And along the way, all of these are independently variable types of APIs that you might bump into. Now, some platforms, using Openshift as an example, and Fuse, provide support for all of this. And we can wrap it up with Jenkins pipeline, right? So if you want a full CI/CD platform right out of the box, great. But the key thing is, and we certainly embrace this at Red Hat and with Openshift, is that a lot of companies have their own standards for this, whether they're using Bamboo or TeamCity or Jenkins, and they might be building their own, or they might be building their own Docker images, right? Or excuse me, Docker formatted container images. So in that case, you need a platform that can deal with that as well. So that's, I think, a critical element here when you look at cloud adoption is saying, how open is the platform based on how I'm working today? And then the second thing is not to get too wrapped up in this idea of redoing everything. Like everything has to be purpose-built for this cloud-based architecture, right? That you have to just redesign everything from scratch. The tools you use might be different, right? Some of the technology you use might be different. But these platforms are perfectly suited not only for the really fancy greenfield microservices that we see, right? But also for just traditional integration problems, right? Your traditional apps, like we saw this in the lift and shift slide, you can pick those up and drop them in the platform and get immediate value of running on a container platform, right? So when you go back to justifying a budget to do this, right, or pitching this to your internal teams, think about that incremental value in terms of how you build a roadmap for moving to this type of platform. That applies both to the existing integration you're doing today and the integration you want to do tomorrow. Okay, so I mentioned there's a story, so let's talk about this story. So who here has heard of the microservices API gateway pattern? Steve and I had a conversation about this, okay. It's kind of like a common one. It's really confusing because the microservices movement said, like, we have this pattern called API gateway, which is basically most microservices applications consist of not just one microservice, but lots, like 3, 5, 12, whatever, right? And the idea is you have a mobile client that actually wants to talk and take advantage of this application, okay? And you have a choice there. The mobile client can be aware of those 12 internal microservices and do all of the dispatch and data mapping and all this kind of stuff on its own. Or you can front that with what they call an API gateway, right? Which is basically a compositor or a facade that fronts that and gives the mobile client a single API to talk to, and it hides all the details about the internal microservices architecture. So if you have experience in API management, this is totally different or quite different from what the API management community thinks of an API gateway, but we'll just leave that alone for now. So this is API gateway pattern, right? So let's talk about what this really means in terms of a cloud-based architecture. First consideration that even if you were doing one of these, let's say you're a unicorn company, right? And all you do is greenfield. Forget the brownfield. We set it on fire. That's why it's brown. So even if you're doing greenfield, you have this problem of once you have more than a few microservices, they're going to start to self-organize, right? So in the microservices camp, there's this idea of, domain-driven design. There's this concept of bounded context, right? And what that means is you own your own data model, right? And basically services kind of self-organize around shared data models. And what happens is that you get more than a couple of these things, and people start representing customer as very different domain models, right? Or slightly different domain models. Doesn't really matter. As long as they're different, they don't interoperate anymore, right? So how are you going to solve this problem of building a single microservices application where the microservices in that application all think customer is something a little bit different, okay? Second problem is the rest of like the 99.9% of your existing IT infrastructure that's not a greenfield microservices app, right? So these customers that we're talking about are probably stored in CRMs, ERPs, databases, your own custom apps, wherever, right? Inside your organization. So when you take on this idea of developing new microservices-based applications, does it live in a vacuum, right? Or does it connect to your existing data that you have in your enterprise? And of course it connects to your existing data. And how are you going to do that, right? Does it expose a RESTful API? Maybe not, right? Probably not. So how are you going to bring that into this, this microservices architecture? And then there's the dirty word of governance, right? Which is necessary everywhere. No matter what anybody says, you absolutely need governance. No company allows anybody to just deploy to production whatever code they want, right? So there's some fundamental concept of governance everywhere. And when you talk about APIs in a microservices architecture, there's some very real concerns there around rate limiting and throttling, right? Security, how you're actually onboarding new users to actually get them into the platform, right? Establishing API keys and this type of thing. And then doing analytics and metrics around those APIs. You know, if you think of like a current application you have today that exposes an API, right? And you monitor it maybe with JMX or like, you know, some other console. Imagine when you now break that up into 25 discrete APIs in a microservices architecture. How are you monitoring that, right? Very important consideration. So from our standpoint, and I'm doing this completely in a vendor neutral way here, I'm trying to say the value of a container platform and kind of an agile approach to this problem space. If we just sat down and said, how would we address these concerns, right? So again, this is taking the API gateway pattern. You have a single mobile client, and it talks to a single API, right? So I need an API proxy that's going to do all that cool governance stuff I just talked about, okay? And that's a separate concern. Some clients will need a lot of governance, some won't need any, okay? So I want that to be an independent thing, independently configured, independently scalable, but it's part of a functionality that I need in this platform. Likewise, I might need integration APIs, not a centralized bus, but integration where I need it. If I need to do some data transformation in between microservices, I want integration there, right? If I want to do some basic routing to aggregate 3 downstream microservices, I want integration there. If I'm going to connect to these legacy type of SOAP or database, relational databases that have all my data in them, right? Then I need integration to do that for the connectivity, all right? So all of these should be plumbing in the platform itself that basically allow you to use them when needed instead of building your application around kind of this centralized ESB concept that Samir was talking about earlier. Okay, next thing I want to talk about, so we talked about strategic, we talked about technical, and now I want to talk about the line of business user. And in my area, this is a new area for us really at Red Hat. Fuse as a platform, Fuse is our enterprise integration solution at Red Hat. And traditionally has been very popular with domain experts in integration and developers. It's super flexible, very easy to pick up. It's a technical tool, okay? Within the integration market, there is now evolving, or emerging, I should say, a new class of integrator that is not a hardcore integrator, like hasn't been in the business for 10, 15 years, right? Maybe has some development skills, maybe not, but doesn't want to write code to solve integration problems, right? And this user has a lot more power today than they used to. They have their own budget, they can go secure software, and this is what we're seeing with a bunch of SaaS adoption. All the numbers that Maureen was throwing out earlier, this explosion in SaaS is this type of user with budget going out and securing software. And they don't really care about the norms that we cared about back in the day of like making a technically pure decision or something like that, right? They're just like, get it done. And there's software out there that'll help me do that. And so they believe very much in self-service. And the funny thing is that they don't realize at first that there's this latent need for integration with SaaS adoption. Because guess what? No 2 SaaS providers share data. They all have their own data lakes, right? So the first thing you do, even just the degenerate case, the first piece of SaaS software you adopt, you're presented with a problem. How do you integrate that SaaS software with your on-premise systems of record, right? If you're an aggressive adopter of SaaS, you move completely into the public cloud and you only use SaaS-based products. you still have the issue of integrating those systems on the web, in the cloud, right? So that's kind of what I want to talk about now is how we can actually take the really exciting technology that we've talked about today, whether it's the ability to create APIs or interact with APIs, running on a fully cloud-native containerized platform, using Fuse for integration. How can we package it up and appeal to this type of user? So I've tried to do it in a product-neutral way, just to mention, as Samir already said, the 3 pillars align to JBoss Fuse, OpenShift, and 3-scale API management. What I'm going to do in this talk is really just focus on Fuse for this last bit, and when I do a demo. And when Samir talked about this, he talked about how Fuse provides this concept of distributed integration. And what does that mean? And to me, it's really 2 dimensions to that, okay? The first dimension is putting integration where it's needed, okay? We don't necessarily need a centralized DSB anymore. Maybe we do. In that case, no problem. You can use it for that, right? But a lot of the new development we're doing to be more agile, to adapt to these new types of evolutions in IT, is to just take a little bit of integration, little data transformation, little connectivity, little routing, and put it where it's needed, right, in the applications and microservices I'm developing. So we talked about that already a little bit with the microservices API gateway pattern. And the other aspect is to address that organizational concern of not only do I need to put integration where it's needed, but allow it to be adapted based on who wants to use it, okay? Is a classic developer a very technical person using integration, or is it going to be more this line of business person that understands business data and business processes, but is not a hardcore developer? And so that's what I want to talk about today. In terms of where we're at with JBoss Fuse right now, we're actually at version 7 of, or excuse me, 6x in our current release. We're working on version 7, which will come out next year. And I just want to point out that Fuse as a platform caters to all of these types of problems. So you can use it in standalone mode, just for this traditional kind of ESB, hub and spoke type of thing, or embedded. You can use what we call Fuse integration services on OpenShift for scale-out microservices type of integration. And you can use a new capability that we're developing right now called Ignite, which is a web-based experience for integration. So, okay, now we're almost at the demo. And what I want to do here is provide maybe a quick backdrop. So here we are at an event. And let's assume that a lot of people registered for this event. It was very popular. It's great to see the level of turnout we have. Let's assume that we also at this event let people come in day of as well. And we didn't have a record of who they were, this type of thing. And yet we always want to follow up with people after these types of events to get their impression, see how things went and this type of thing, and establish a relationship. So if I'm at this event, what I really like to do is in my presentations, and I should have done it in this one. Oh, that was a total fail on my part, sorry. But put a hashtag in the presentation, right? That says, hey, if you're at this event and you have a Twitter account and you want to share some ideas of what you think was great, what you think could be improved, send out a tweet and just let us know, okay? And what I'd like to do is I'd actually like to go collect all of the people that tweeted about the event, and I like to load that into Salesforce so that I can have a team go follow up with those users. If they had a good experience or a bad experience, just to follow up and start to have that kind of touch point with that user. So this is like a pure SaaS-based integration scenario, right? We're going from Twitter. We have some data there that we need, and we're going to take that data and we're going to put it in Salesforce. Okay, so very, very straightforward type of integration, and really catering to this higher level user. Anybody on our marketing team should be able to solve this type of problem. Okay, hopefully the screen resolution is good enough. I'll talk about what I'm doing the whole time, so if something's not evident, let me know. Please somebody raise your hand if you're confused about where we are at any given time. So right now, I mentioned this Ignite interface. So this is this kind of iPaaS or integration platform as a service, web-based integration experience that we're adding to Fuse in the next major generation of Fuse. And what we want to do is satisfy that type of what Gartner likes to call the citizen integrator, but I'll just in general say someone that doesn't want to write code to solve integration problems. And what we want to use this tool for is solve this problem of integrating Twitter and Salesforce. So the very first thing I'm going to do is I'm going to create a connection here. So that I'm using the iPaaS right now, and I want to create a connection to Twitter and to Salesforce. So I'll go ahead and click Create a Connection, and I'll click on Twitter. And so underneath the covers, I'll spoil a little bit of the surprise at the end here, but this is just using Fuse, the full power of Fuse and OpenShift underneath the covers The user that's using this interface is not aware of that at all. But when we talk to these Camel as a project, the core of Fuse is Apache Camel. Has connectors, I don't know, like 250 or 200 components or something like that. It's got a lot of connectors. In this case, we're using the Twitter connector underneath the covers. And it takes a lot of a very technical configuration detail. But here what we're saying is that we're actually just initiating a normal web-based OAuth flow that any normal user could do. So I'm already logged into Twitter, so I don't need to log in. But it's asking me for an OAuth grant just to say, hey, can your integration solution talk to Twitter to act on your behalf? And I'll go ahead and authorize it. Underneath the covers in Camel, this is creating a Camel URI with a bunch of technical details about the location of the API, the login information, all the OAuth stuff. But that's all completely transparent to the end user. So I just get to say demo Twitter. Oops, and it would, I guess it doesn't really matter, but I should spell it right. Test instance of Twitter. I'm just giving it a name and a description. And we'll say create. Excellent. And if I wanted to, like in this case, it was actually a pretty simple OAuth flow, but if I wanted to, and this had a lot of configuration associated with it, it's nice to actually validate these connections. I can go and validate them when they're created so that I can make sure before I go and integrate with these systems, I can actually connect to it successfully. So I get that first connection in the bag, and the next thing I'm going to do is create a Salesforce connection. Same type of situation. I'll connect to Salesforce. I'll go through an OAuth flow. You can see, if you watch closely, it actually did an HTTP redirect, went to Salesforce. Salesforce doesn't even require me to give a grant because it's already cached that information. So I'm really right back just to giving a name for it. So we'll say dev Salesforce. Dev instance of Salesforce.com. All right. And we are off and running. So we've created our two connections now, okay? And the next thing I want to do is integrate them. So I'm going to go to integrations and create a new integration. And Ignite's asking me where to start from. So we want to start from Twitter. And again, underneath the covers, this is using APIs. So going back to the APIs is the focus of everything we're doing with integration. All SaaS software provides REST APIs, or most of them do, right? So we're really just doing API-based integrations here within the product. So there's a number of actions available in Twitter. What I'm going to say is, anytime my account is mentioned, right? So in the case of this event, it would be the Red Hat corporate account. I want to actually trigger an integration. So we'll go ahead and click mention, and I'm good to go. Now I have to tell the integration where the data is going. So I'm starting from Twitter, and I'm going to Salesforce. Salesforce, as a more complex or sophisticated piece of software, has a lot more operations available. In this case, what I want to do is create or update a record. And what that means is that if I receive a tweet from someone, I want to capture their contact information from Twitter and create a new contact within Salesforce. If a contact already exists for that person, I want to create a new one. I just want to update it. So I'm going to say create or update. You probably saw a spinning circle there for about 3 seconds. And what's happening is Ignite is reaching out to my Salesforce account live to determine exactly what objects are available in that account. So it's a different experience for every user based on how their Salesforce is configured. And this is a key element because everyone customizes Salesforce. No two Salesforce installations are the same. People add objects, they change objects. So the integration solution has to be dynamic enough to recognize that and work with the end user. So in my account, I got heaps and heaps of objects because it's a developer account. I'm just going to select contact because that's what I'm interested in creating. So I'll say next. And because this is a create or update, what I need is a unique key, basically to say, how do I know whether this contact exists or not? And in my instance of Salesforce, I've modified the contact object to contain a field called Twitter screen name. So I'll go ahead and select that. And again, all of this was pulled dynamically from Salesforce as part of connecting to the Salesforce instance. So I'm done. I'm going from Twitter mention into Salesforce. Now, two other things I need to consider here. First is, Red Hat's a big company. Lots of people tweet about Red Hat. Maybe I don't want every tweet about Red Hat. I just want the ones for this event. And I mentioned adding a hashtag to our presentation so that people could tweet about it. So what I want to do here is add a step to this integration flow that allows me to implement a filter. Underneath the covers, there's a very powerful expression language for doing this within Camel. But for this type of user, we don't want to expose that directly, even though it's going to get reduced down to that at runtime. What you see is basically like a mail filter. You might consider configure in Gmail or a mail client that you have. And what I want to say is I want any incoming data to match all of the following constraints. First, it's got to match some data that's coming in. And the cool thing here is that we've actually detected the data that's coming in from Salesforce, from Twitter, excuse me. So we're aware of that at runtime. So in this case, I'm just going to say text. And then I'm going to say contains, but it can be any type of operation. And then we'll just say RH Toronto. So if a tweet mentions my account and has that hashtag, I want it to proceed and load into Salesforce. Of course, I can't take a tweet and load it directly into Salesforce. That's not going to work. So I actually need to add some basic data mapping here. So go ahead and add a step and select a Datamapper. And now I can see, again, Ignite's type aware. So you don't have to go define the types that are used. We've discovered those for you. So it already knows what we're doing. So I'm going to go down here and look and see user. This probably has name and this kind of thing. Looks like there's a lot of fields, so I'm just going to filter that down. All right. And we're going to say, I want to take the user's name and map that into first name. And looks like there's first name and last name. So I'm going to go ahead and separate that field into 2 fields and add an additional target, which will be last name. There we go. Great, I'm splitting that. I want to take the screen name and map it into Twitter screen name so I know whether it's a duplicate or not. And then I think one thing that will be useful is if I take the text of the tweet and I map that into the description field of my contact, then the people that are following up with these users will actually have an idea of what they said, which could be useful. So I can, the nice thing is here, I can kind of summary view of my data mapping. I'm going from name to first name, last name, screen name to screen name, text to description. That all looks great to me, so I'm going to click done. I'm going to go ahead and publish this. My integration is complete. We'll say demo integration, and then my demo integration. Very imaginative with these descriptions. So we'll go ahead and click and publish. Okay, so a couple things. First, everything I'm doing right now is actually running in the public cloud on Openshift Online. Openshift Online is Red Hat's multi-tenant public cloud PaaS, basically, right? Container platform. So the iPaaS is running on top of that. No tooling is installed locally on my machine. When I'm deploying this integration that I just created, it's going to run on Openshift Online. So everything's running in the cloud. Let's go ahead and pop. So as this is deploying, so the other point I was going to make, as I watched the spinning, mesmerized by the spinning beach ball, that when we've created this integration at this very high level for this type of user, it's actually being built as a container image to be deployed within OpenShift. So you're getting all the power of the underlying platform, but you have a real nice interface on top of that. So if I go back into the actual OpenShift console, this isn't something I expect this higher level user to do, but we're friends, so we can peek underneath the covers to see what's going on. Let me go look in OpenShift and see what builds are happening here. And so we have a build that's running, and if I go and view the log for that build, I should see that this is basically just a typical Fuse app. If I scroll all the way up, keep going, keep going, keep going. Lots of Maven building going on here. Lots of Maven building, come on. Try to get to the top. It's a race. Am I going to make it? 720p is doing me no favors right now. All right, we're not. We're just going to go to the end. That's a long log. So basically, the build succeeded, pretty snappy at 30 seconds, right? And basically what it did is, remember we said that container toolchain? So it built the application, right, into a Spring Boot fat jar, and then put it inside a container image, okay? And then deployed that within OpenShift. So if I come back in here and look at pods that are available, I can see that my integration is actually up and running. If I go check out the logs, I should see that application is starting up right now. Here we see there's a basic Spring Boot app underneath the covers with Fuse and Camel inside of it. And if we follow it at the end, let's just see, we've started the application. So our application is good to go. Should be able to come back here, go back into done. This is just refreshing now. It'll say active in a moment. Our integration is effectively deployed. So, it's active, we're ready to rock. So let's actually test this out. So just to make sure there's no magic up my sleeve. So here's my contacts here. This is my Twitter account called Citizen Babo, and I'm just going to create a tweet, and we'll say mention of my own account and great demo. Now that's not very nice, right? Saying it to myself. Okay, demo. You can do better. And then we'll say RH Toronto. Hopefully I spelled that all right and that matches my filter. Okay, so I've tweeted that. Now this integration is up. It's deployed in OpenShift Online. It's running, and it's polling Twitter every 30 seconds. That's the default polling profile for that. So if I manage to catch the sampling interval right, oh, there it is. So cool. So I go into Citizen Babo, and here I see it map the name, map my Twitter screen name, and has the text of the tweet, right? So really, really basic example, but the thing I want to impress on you is that you're getting the advantage of this really advanced container platform under the covers and advanced integration technology with Fuse, but you're doing it at a level where you don't even really have to interact with that, right? So this technology can really enable new classes of users in the enterprise to participate on the same type of strategic platform that you're doing your very advanced development of microservices. So as I mentioned, this experience, this web-based experience is called Fuse Ignite. Ignite, when it runs, it's running on OpenShift Online. Everything's containers, okay? The infrastructure itself, everything behind the UI, all the data mapping, everything's running as a container. When you create an integration and it gets deployed, that's running as a container, okay? Great thing about this, remember when we talked about with the cloud-based platforms, how you want the flexibility to deploy in multiple environments. Because this is all developed on Kubernetes and OpenShift, it means it can run anywhere OpenShift runs. So if you run it in private cloud, self-managed, you can do that, right? So on-premises, essentially. You can run it in the public cloud on Azure, GCP, or EC2. Or you can run it on OpenShift Dedicated, where Red Hat manages, or OpenShift Online, right? So you have the full gamut from private cloud to public cloud to vendor-managed public cloud. The other main advantage here that we didn't really get into the demo, but I just want to kind of tease it because it's a feature we'll have in our next tech preview release, is the idea that, yeah, this is great for this citizen integrator to come in and create this integration, and they didn't have to write any code. But integration is a really complex area, right? And so there's some class of problem that you don't have to write code for. But what happens if you do? And what happens if you adopted this type of iPaaS solution and the platform gives you nowhere to go, okay? The key thing, as we saw, is that all of these integrations are actually Fuse applications under the covers. So any developer can come in and contribute code to these integrations that can just be called as a step within the integration flow. And the idea here is that now we have the ability for citizens to take on the integration that developers don't want to do anyway. The real, basic building blocks of integration, right? But when they need help from a developer, there's a very easy hook for that developer to come in and help them out. So, last thing I want to say is a call to action that everything I showed you here today is available for evaluation now on OpenShift Online. So if you go to this URL here, honestly, if you just Google Red Hat Fuse Online, which is the name of our technical preview product for this, you'll find this and you'll get the slides so you can go to it. But there's a link there. There's a nice little red button down there in the bottom left corner that says join the technical preview. I approve the accounts. I'll definitely hook you up. So please, we'd love to get your feedback. So please give it a shot if you think it looks cool, and register and give us some feedback.